All right, let's jump right in. It feels like artificial intelligence is just everywhere. And the whole field is changing so incredibly fast that it can be a real challenge to keep up, even if you're deep in the tech world. So today, we're going to break down 7 key AI terms you really need to know as all this stuff keeps evolving.
I mean, seriously, it has gotten to the point where even our toothbrushes are getting AI updates. It sounds kind of ridiculous, but honestly, it's the perfect example of just how deeply this technology is weaving itself into every little corner of our lives.
And that's the big question, isn't it? Once you get past all the marketing buzz, what are the actual core concepts that make these incredible, sometimes weird, systems really tick? Well, in this explainer, we're going to pop the hood and see what's going on inside.
Now, to make all this make sense, we're going to stick with one example the whole way through. Let's imagine we're building an AI to be our personal travel agent. Something that can book our flights, find hotels, and plan an entire trip for us. I think this will help make these pretty abstract ideas a lot more real.
Okay, so let's meet the star of our show. The first, and maybe the most important term to get your head around, is the AI agent. This is the big idea behind our travel planner, and really so many of the next-generation AI systems being built right now.
So what exactly is an AI agent? Well, unlike a simple chatbot that just sits there waiting for your next command, an agentic AI can actually reason and act on its own to get something done. You don't have to micromanage it. You just give it a mission, like, hey, book me a trip to Paris, and it starts figuring out all the steps to make that happen.
And the way it works is in this constant loop. First, it perceives its environment, so it sees your request for a trip. Then it reasons, and it comes up with a plan. After that, it acts on the plan, maybe it starts searching for flights, and finally, it observes the results of that action, and then it repeats the whole cycle, tweaking the plan until your trip is fully booked.
Okay, so for an agent to reason and make these complex plans, it needs a really powerful brain. And we're not talking about just any standard AI model. This is a special type that's designed specifically for this kind of step-by-step thinking.
And that brings us to our next term, large reasoning models, or LRMs for short. You can think of these as specialized large language models that are trained to think through problems in a sequence. So instead of just spitting out the first answer that comes to mind, an LRM generates this kind of internal chain of thought to break down a big task. This is exactly what our AI travel agent needs to plan a complicated multi-stop vacation.
You've definitely seen this before. When you ask a chatbot a really tough question and it pauses and says something like, thinking, before it gives you the answer? That's the LLM-RM in action. It's literally taking a second to work through that internal reasoning process before it shows you the final result.
All right, so our agent has a brain. It can reason. But a brain isn't much use without knowledge, right? Where does it actually get the information it needs to think about things like real-time flight schedules, or hotel availability, or which restaurants have the best reviews? This is where our next couple of terms come into play. These are the technologies that act like the agent's gigantic, always-on digital library, giving it access to fresh, up-to-date, real-world information.
It all starts with something called a vector database. Now, instead of just storing text or images as they are, this special kind of database converts them into these long lists of numbers called vectors. And what's cool is that this vector captures the meaning of the data. It's like a map where related ideas are grouped together. So Paris, France, and Eiffel Tower are all neighbors, but Paris and, say, peanut butter are on opposite sides of the map. This lets the AI search for things that are conceptually similar, not just things that share the exact same keywords.
But, having a super smart library is one thing. The AI needs to know how to actually use it. And that process is called Retrieval Augmented Generation, or RAG. This is really the secret sauce that makes an AI feel so smart and aware of what's going on right now. It takes your prompt, and before the AI even thinks about it, it juices it up with fresh, relevant info that it pulls from a knowledge base.
So here's how it works with our travel agent. You ask for a quiet hotel near the Louvre. RAG immediately turns that into a vector, zips over to the vector database to find hotels with similar meanings, and pulls out the best matches. Then, and this is the key part, it adds all that fresh info right into the original prompt before handing it over to the LLM brain. It's like giving the AI the perfect cheat sheet for your request.
So let's zoom out for a second. We've got the agent's brain and its library. But how does all of that connect to the real world? And how are these massive systems built to be so powerful, but also, efficient? This is where something called the Model Context Protocol, or MCP, comes in. The easiest way to think about this is like a universal adapter for AI. For our travel agent to actually book that flight, it needs to plug into the airline system, right? Well, MCP creates a standard way for the AI to connect to all sorts of external tools, booking systems, your email, anything, without developers having to build a new custom connection for every single one. It's a game changer.
And to make these giant models run without, melting a server, we have an architecture called Mixture of Experts, or MO. Instead of having one single massive know-it-all model, MO breaks the model up into a whole team of specialists. When a request comes in, a router figures out which experts are needed for the job and only activates them.
The power of this is just immense. It means a model can have a truly staggering number of parameters. We're talking billions or even trillions, making it incredibly capable. But for any single task, at any given moment, it's only using a tiny fraction of them. This is how you get that massive scale in AI power without the computing costs going completely through the roof. It's super clever.
So we've covered the tech that's powering AI today, from agents to experts. But where's all of this going? What's the endgame? Well, the last term on our list points to the theoretical and potentially world-changing goal of all this AI research.
And that destination is artificial superintelligence, or ASI. This is the big goal for all the frontier AI labs. Now, it's absolutely critical to understand that AI is, for now, purely theoretical. It does not exist. We don't know if it ever will. But what it describes is an AI that isn't just as smart as a human, but one that possesses an intellectual scope that is far, far beyond us.
To really get it, it helps to compare it to another term you might have heard, AGI, or Artificial General Intelligence. AGI is an AI that could do any cognitive task as well as a human expert. ASI is the step beyond that. It's an intellect so vast that it could potentially start redesigning and upgrading itself, getting smarter and smarter in this kind of endless runaway loop.
If an intelligence like that ever emerged, it would be a fundamental turning point for humanity. I mean, it's the kind of thing that could either solve all of our biggest problems or create entirely new ones that we can't even begin to imagine. And with that little thought to chew on, you are now up to speed on 7 of the most important terms shaping the future of AI.